WMI Exploitation. I'm Michael Gough. I'm the co-founder of LogMD. And how many people here have heard of the Windows logging cheat sheets? Oh, man, that's awesome. All right. So this whole thing started from that project, which was based off of an attack from the WinNTI group in gaming. And it started with one cheat sheet. There's now 9. If you're unaware, we've released 2 new cheat sheets, the Windows attack logging cheat sheet and the Windows LogMD attack logging cheat sheet, which adds Sysmon and LogMD to the attack matrix. I'm a Bluetooth Defender Ninja incident responder. Hello, my name is Michael. I'm a logaholic. Okay, you are awake. See, the clapping worked. I am the co-creator along with Brian Betcher. We are up at the booth. We are sponsors of Derbycon, so thank your sponsors. Okay, you guys are awake. I like this. This is going to go good. I'm also the co-host of Breaking Down Incident Response podcast. If you're not familiar with Breaking Down Security, Brian Betcher and I started the incident response to try to give you guys a real, I can take this back to work and do kind of stuff of what we really see. And then I got this yesterday. I'm rather flattered with this. I did not attend SplunkConf this year. I get asked all the time. But I got this tweet where it turns out, I don't know if you're aware that SplunkConf has a boss of the knock, and it turns out the winner of the challenge named their team Hacker Hurricane, my Twitter handle. So I guess one of the reasons you should listen to this talk or follow what I preach and tell people is because even these guys, they won the boss of the sock contest. So I assume they're using the food that I spread with the cheat sheets and whatnot. But that's really cool. I've never had a team named after me, so I'm real happy about that one. So WMI, some say WMI, okay, so it's either one. WMI doesn't work when you say WMIC, so WMIC, so no, it's WMIC or WMI from my perspective, but you will hear the word WMI, that's probably what they mean. So why do we care about this? One, because no one wants to be on Brian Krebs' list, so that's one reason why you should care about WMI. Now, the other is the MITRE attack framework, or a collection of, they don't really want to call it a framework anymore, a collection of tactics and techniques from the hacker community, and they've mapped these out. WMI is specifically referenced in 2 of them and mentioned in 27 other techniques. That means they're using WMI to query the system or get information or do something. And that doesn't include where WMI is using PowerShell, where they've referenced PowerShell. So WMI is pretty littered through the attack MITRE framework. And so I recommend that this is a good way to map it. If you want to see this mapping, come up to the booth and we'll show it's all color-coded and whatnot. And again, they use this for a lot of purposes. WMI is built in, much like PowerShell, but Windows doesn't log it very well, like really badly. So there's a lot of opportunity here for pen testers and hackers to utilize WMI, which has incredible power for the system. Query the system information, right? You know, who's logged in, who's doing this, what's running on the box, etc. Remotely execute payloads, a really bad thing. Remotely persist, so it even has a capability of persistence. So we need to understand what can be done with WMI, so we can stop the Matt Grabers and the Dave Kennedys and the Ben 10s of the world, and detect them in regards to their tests and or the hackers' bad foo. Much like we see at Evan Kerr when he used to work for Mandiant, doing talks in WMI, and now with Endgame. And again, it's one reason we created this attack matrix is because of WMI, and we added a lot of updates to LogMD with the latest version, where we are probably the only tool that queries the WMI namespace, not just the root subscription, but all of the WMI namespace. Thanks, Matt Graber, for that one, and his Black Hat 2018 talk. We went back and filled that hole. So what is WMI? Well, it's the Windows Management Interface. Think of it as SNMP on steroids, right? SNMP just sends an information alert out to a system to collect and tell you, hey, the router's down, or hey, the CPU's hot. But this thing can actually interact with the system, WMI unlike SNMP. You can query all kinds of information about the system. You can even write scripts or applications that can actually do administrative tasks or actions, thus stored in the WMI database. And so it's also part of the operating system, right? Living off the land's a big thing here. This is a reference slide. This comes from Matt and other talks where basically all the components. You got WMIC, the command line utility. There was a recent write-up about WMIC being used from a .link file to go out and fetch a payload from the internet. And again, that would bypass whitelisting because WMIC is a trusted Microsoft binary. You got VB script you can use, JScript, WBM test as a testing utility. You can utilize that and potentially misuse that. You got C++ and COM, on-demand compiling can happen. You've got Windows Remote Management, WinRM stuff. You've got the Windows Remote System stuff. You got the WQuery language, the whole query system that WMI uses. You got some DLLs. You got COM. And again, you got WRM with PowerShell remoting in there. So boom, you launch PowerShell and I can start remoting around your environment. WMI as a service is running, which means sideloading can occur. The SIM objects, which is the databases where all this stuff is stored, can be used for persistence and a way to store your foo, PowerShell scripts, and or binaries. And of course, there's a repo, and you can use MOF files to install all this. So anybody concerned yet? So where does it live? The first thing we need to understand is where these pieces and parts exist in the system. One of the big ones is WBEM. I highly recommend you monitor this directory. This is where WinNTI dropped some malicious DLLs, taking advantage of WMI loading on a server pretty much every 5 minutes, thus loading the bad DLL, which would then load the good DLLs, and the box was infected. No typical AutoRun. This is a sideload scenario. You also have to look in WBM/repository. That's where the WMI databases live. And the 3 utilities, WMI AP, WMI AP SRV, and specifically WMI PRV SE, which you're going to see used a lot in Espresso. Watch the execution of this one. This is really important. This is where a lot of the foo that the pen testers and bad guys will use to query your box and do malicious stuff. And of course, the databases, index, BTR, and objects.data. They are databases, but there's a lot of stuff in clear text, so you could just string out these databases or use a tool, whatever, script, Python, whatever you can find, that will actually query through the database and report to you what's in there, like a tool like LogMD or anything else. Some utilities do exist, WMIC and System32, so you're going to watch the execution of that. So there's lots of components here that WMI has. Tool failures, well, laptop in a dishwasher isn't one of them. And I got this on Twitter. I just thought this is awesome. He's clearly a tool. And so I just had to include this because, yeah, that's, he is, and as the Brits and Aussies say, he's clearly pissed. Anyway. Tool failure number 1 is Windows Sysinternals AutoRuns. Again, based on Matt Graber's talk at Black Hat, he found that he can modify other components within other namespaces, not just root subscription. Unfortunately, the AutoRuns module of Sysinternals only looks at the items in the root subscription, so there is a gap here. So be careful there, and definitely watch Matt and Lee's talk from Black Hat. Sysmon's another one, similar scenario. It unfortunately only looks at the root subscription. Nobody's really done a lot of research, and so that's kind of where we all stopped. I even admit we did that with LogMD initially because that's what everybody else does, until, of course, Matt Graber talks, and we always have more work to do when he talks. And again, Sysmon does not see WMI calls at all. There's nothing in Sysmon to do this. It doesn't see Windows Remote Management, doesn't see that, doesn't see any authentication, and doesn't see PowerShell. So there's some things that Sysmon just does not see that you'll have to use built-in Windows logs to do. And again, do you have a tool? I want to see some hands here. Do you have a tool that searches the WMI database, that searches for WMI persistence, that searches for WMI execution, that searches for WMI authentication? Are you catching my drift? I don't see a lot of hands, so it's a gap. Seriously, is a gap. This is more of a hit and miss. Some EDRs will do pieces and parts based on what executes. If WMIC goes to the internet, it's probably going to flag from that perspective, but there's a lot of gaps here, what they do and do not look at. And so this is a perfect opportunity to hunt in your environment for these kinds of things, and we're going to talk about that. So how do we get pwned by WMI? Well, of course, Arnold, WMI scares me. Again, I don't want to be on Krebs' list. Few detect it well. There's definitely a challenge here. I'm going to talk about what those challenges are and how you can get better at this area. And I highly recommend you do get better in this area, or Tyler's going to take advantage of you in his malware analysis class. Right? It can be very low noise if it's done well. That's the other really important point here, which I'm going to point out to you in regards to how certain things occur and then what WMI does. It's kind of scary. Honestly, I think the general analyst or typical analyst will blow this by. WMI naturally occurs a lot in the system, so it is fairly noisy by default, and you have to look for these odd nuances to catch what's going on. And of course, pen testers, red teamers love this stuff because of the ability to query a system. Any pen tester, whether it's Carlos Perez or Ben 10 or Dave or Matt, will use WMI to find out what the heck's running in the box, what processes are running, which will tell me what EDRs in the box or what security tools are in the box. And if you want to execute something against the box, all you need is creds. You're a lot better than CactusCon. You hear that, CactusCon, guys? Nobody participate. These guys are fun. I like this. And WMI has tons of capabilities and a lack of tools to hunt for it. So that's the thing. So WMI Pwnage. Again, so many ways. You can install a malicious MOF. So my discussions with Devin Kerr, I said, so MOFs exist in the WBM directory. I can just watch for them to be placed there and executed. No, they can be executed anywhere on the box. Damn it, Microsoft. Sideload of malicious DLL when you drop it in WMI, which I saw with the WinNTI group. Hard thing to detect because on a server, that behavior looks totally normal. There's nothing weird other than the DLL's in the wrong place. And Windows doesn't log DLL loads. Sysmon does. So if you don't have Sysmon everywhere, which most of us probably don't, how many people here are running Sysmon in some capacity? That's actually more than I thought. But yeah, again, not a lot here. So Sysmon does give you DLL. This is probably the number one reason to use Sysmon. It's the DLL loading, module loads, ID7. And again, you can remotely execute WMI and launch malicious code in EXE, a script, whitelist bypass, of course, EXE. So you can launch any of the stuff that Casey Smith talks about. You can remotely install a task and a service. You can remotely launch PowerShell code. Yay! PowerShell has all the power of .NET at its disposal. You can add code or persistence in the WMI database. There's lots of options here. You can kill a running process, aka your security tools. And just ask Carlos about what he does with WMI before he commences his attack. And et cetera, et cetera, et cetera. I mean, the power is almost endless. Moth's going to be installed anywhere. So just saying I'm going to go look for .moth files for something malicious. I think Devin or Matt gave me a malicious calc moth file that I used for testing a couple years ago. And yeah, I can place it anywhere and launch mothcomp space this moth file and boom. You get, basically where it executed from and that's it. WMI AP, ADAP, AP SRV, and specifically PRV SE start and stop on systems, especially servers. More so on Windows 10, more so on systems that have specific hardware like RAID controllers, specialized NICs, storage, etc. You'll see those start and stop. Like in the gaming environment, we had tons of that. It's constantly starting and stopping, starting and stopping. So you really couldn't pull out any malicious intent there at all from just that normal behavior. And then boom, once WMI starts, then poof, you're infected if they sideload a bad DLL. And WinNTI group used this in the gaming, as I pointed out. So you can read up more about that in reports that have been issued about WinNTI. So some Pwnage tools, if you want to play and do some research, WMI LM, WMI Implant, PowerSploit, and PowerShell X Empire. I tested the first two. Again, I tried to stay away from PowerShell from doing the testing that we were doing here. And so this is a typical suite if you want to do your own research. So here's WMI Implant's menu. As you can see, it's pretty extensive. There's file operations. You can cat, you can copy, you can delete, you can download. You can do a listing, an LS, which is pretty funny because it's Windows LS anyway. Search, upload files. So you have total ability to do and look and read and everything else. You can do lateral movement here with command execution. You can do disable WW digest. You can disable WinRM, so you break the ability of people who have WinRM to do, let's say, Conza. You can break that, so now I can't use Conza to go investigate, as an example. I can modify the registry, so I can turn on or off the PowerShell logging registry entries, potentially, until your GPO kicks back in and overwrites them, because hopefully you're doing it in GPO and enforcing them. You can do service modifications, creates, deletes, modify. I mean, a lot of power here. Process operations. You can kill a process, and you can also start a process. So kill security tool A and start malicious payload B. And of course, you can do a process listing because you don't know what to kill until you can list the processes, right? And of course, all kinds of things about users and basic info about the system. Very, very powerful capability here with this WMI implant tool. So let's talk about some more Pwnage. So WMI attacks often use PowerShell once in. Matt Graber said use of PowerShell in pen testing is dead because if you do the logging that's in, for example, the Windows logging, PowerShell logging cheat sheet, you're going to do a pretty good job of seeing what's going on with PowerShell, especially if you upload it to a SIM. So from that perspective, he's looking at other ways to exploit the system, whether it's compiled C or whatnot, or this discussion that he had at Black Hat where he talked about using already existing scripts and other namespaces. So COM and WinRM are also used a lot in the attacks in WMI, so you have to pay attention to that. And COM doesn't have built-in logging. It's only available on some systems that you install it on. There's nothing on my desktop, for example, to monitor COM execution. So how do we detect this? How do we detect this bad foo I just spent 10 minutes telling you about? Well, all OSs are not created equal. If you need another reason to tell your organization to upgrade to Windows 10, Devin and I were talking about this at Sans Thur in New Orleans here a few weeks back, and we both agreed that Windows 10 has added a lot of capability in regards to detection, or at least the ability to collect information from the system to detect. And so if you're using Windows 7 or 2012, some of the items I'm going to talk about are not going to be available to you. So upgrade, 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 and also PowerShell 5 for obvious reasons, better logging. So there's your 1 point. This is what I want and what everybody wants, a typical execution of malware to look like, or any kind of malicious activity. In this case, this is an Emotet Word file that goes ahead and launches command.exe, another command box, PowerShell, and then launches the binaries and then writes the final destination SLS key. This is a pretty typical process tree. It's 8 deep, okay? That's the point I'm trying to make here. There are a sequence of events that occur, and it's 8 deep. So keep in mind, this is what I wish all malicious activity look for, because that's real easy to spot. So let's talk about logging. First thing you need to do to catch WMI is to enable process command line logging. If you look at the Windows logging cheat sheets and you compare them to the CIS benchmarks or USGCBs or Aussie Cyber Standards, they do not recommend turning on process command line. You might catch a password in the logs. Yeah, okay, I can deal with that. I can stop that collection. I can specifically exclude that collection. There's lots of ways to mitigate that problem. So please turn this on if you want to really catch the bad foo. Of course, you can then see moff install. So now, instead of just seeing moffcomp.exe from a process execution, I can see moffcomp.exe space malicious.moff execute. So now I can see moffs actually being used, the name of them, which then I could potentially look for. If it's not on disk, that means somebody executed them and deleted them. That to me is suspicious. Or the next example you'll see in a second. And of course, Sysmon has the event ID 1, which is similar scenario to process 4688 with process command line. Oh, in Windows 10, you do see the parent name. In Windows 7, you see the PID. So there's no association of what that parent name's name was if you're looking at Windows 7 logs. But in Windows 10, you actually get the parent name very similar to what Sysmon gives you. So another reason to upgrade to Windows 10. Process command line tells all. This is why it's important. So here's an example of a Pwnage using WMI that's executing PowerShell, doing a NOP, so no profile. So the stuff in the cheat sheet for older versions of PowerShell say, don't read the profile. So whatever's command line logging is being turned on there, ignore it, or whatever else it's doing. Non-interactive, don't show it to the user. And hidden, definitely don't let anybody see the box. And it's doing a call to WMI class. So this would be a great indication that, yeah, somebody's doing something they're not supposed to. And you would catch this with a 4688 process command line. So there's a great example of the power of this particular item. WMI by itself, when you execute it as a query tool or even exploitation tool, it is not very noisy because each time it executes individually, not in the series of a parent-child scenario that I showed you initially. So for example, here's service host, and this is what it normally looks like. This is nothing here at this point is malicious looking. And here it is launching on the left. So service host is and will be the parent in all cases. And so now that we know that, we can say, okay, let's focus at WMI AP SRV and see what it is it's doing there. Okay, typical normal, but bad foo. Again, these are all single liners, right? Nesting going on here. WMI activity logs, there is a log. It's called the Windows, it's in Microsoft Windows, so that's subfolder of the event logs. WMI activity operational. This is a log you want to pay attention to. Windows 7 or Windows 10 or later or server for sure. The event ID you want to focus on is 5861. This is where anything new is created. Now those fails with AutoRuns and Sysmon, yeah, any namespace alteration and addition will be in this log. So that is something that Windows 10 does that the other two tool failures do not. So Windows logging is better than the other Sysinternal tools that I just spoke of. But there are other event IDs, so you can play with those. But this 5861 is the one you really want to pay attention to. And this is the only one that that catches something that was added to a namespace. All of them. So it addresses Matt Graber's talk as well as what we're doing in LogMD. But not how. You don't know how that thing got created. Process command execution or other things that I'm going to show you will collect this. And again, use that command line because that is how it got there. Whether it was a moffcomp, whether it was a script, whether it was PowerShell, all that, you'll definitely need that log enabled. If you do have the Microsoft Windows Distributed COM, collect it, look at it, and look to see what COM objects are being called. You won't see this on workstations. I've yet to find one on a workstation. I do see this on some servers. It's not on my personal domain controller, so there's something you have to add and install that I just generally don't do. But definitely watch out for this because COM objects are a big part of WMI. So WMI, let's look at what it does when it queries the system. Authentication. Yay, Windows 10 and 2016 server to the rescue for the win, big time. I was real surprised that I stumbled across this. It turns out there is a unique authentication that occurs when WMI talks to a box in Windows 10 and 2016 server. So here's an example. There are debug logs and trace logs. So if you got a tool that can do that, great. You'll get the calls of actually what WMI is executing. But it's not practical for us to go turn on debug and trace log. Hey, IT, you want to turn on trace and debug for me everywhere? Yeah, I think the big answer is going to be no. So it's not very practical for us to rely on that. You're going to have to look at an EDR tool that might do that, or another solution. But again, all you need is creds. So you need a user account, right? The bad guys will have gotten a cred through a myriad of ways, right? Mimikatz can they can do Kerber roasting, right? Responder on the wire, keystroke logging, or a phish where the user just gives up the creds. Somehow, way from a manner, the bad guys will get the creds. The pen testers will get the creds. They win almost all the time, if not all the time, right? So, of course, it has to be a valid user, okay? So once they do that, unless, of course, it's, WMI, the clue is what is launched. So what is WMI actually doing? You saw Service Host launching WMI, doing typical system management stuff, but does WMI then do something else? And that's what we're going to look at. And Windows 10 definitely shows you some cool stuff. So here's an example of the authentication I was talking about. The unique thing here is there is actually an impersonation and identification. I'm looking at this from a lateral movement perspective, workstation to workstation. So VJ's box, bad box over VJ talking to Kevin's box. You will see this show up in the local logs. This will not be a potential domain authentication unless they crack that and are using it. But they're going to use probably a local cred that they somehow harvested, local administrator or your users or admins. How many people want to raise their hands and say their users, some of their users are still admins? And you see this dual auth. You will not see this in Windows 7. So suddenly there's an oddity and authentication that occurs when WMI is querying the box. Now this is a real surprise to me because 4624 is just off, but the fact that there's two of these is keen and something you can definitely focus on. Source and destination, firewall logs. I love the Windows firewall logs. It's not just bad IP1, talk to bad IP2 or good IP2 to try to compromise it. It is that this application from .1 talked to this box on .2 and also the ports that it talked on. So you get some more information, the context, inbound, port 137. I know a lot of us don't turn on the Windows firewall in the corporate world. That's okay. It will still log. You do not have to enforce to get the logging. Very cool feature with Windows in that aspect. And so you can tell what exactly is happening. Service host is making a connection to the box. Okay, again, ask yourself, why should Workstation 1 being talked to Workstation 2? Let's look at a typical ransomware. The podcast we're coming out with here after we get back will be about a breach that was shared with me where it was a ransomware attack, and they got in through RDP on the internet. Yeah, well, that's the way that goes. And they laterally moved across the environment to 150 machines and infected it. This is where you'll see that lateral movement, not in your domain logs for the most part, other than possibly a lot of logins. But the fact that you can see what ports and what's not going on here is quite valuable. So think about, in your lateral movement, Workstation 1, should it be talking to Workstation 2, 3, 4, 5, 6, 150? The parent-child relationship is key, right? Service host, we already talked about, is calling WMI. So that in itself isn't, and most of us will filter this out, and I'll tell you I have, because this generally has no value. Okay? But what if I want to push a payload? I've authenticated the box, I queried it like I just showed you. So again, lateral movement. So here's a network login, type 3, to, again, NTLM, to play target and attend target, and hacker's the guy, just connecting to it so that we know that that's happened. And again, net use looks like this. This is what a typical net use looks like. So you could actually look for, again, Workstation 1, talking to Workstation 2, a lot over 445, is not normal behavior. Your users don't map drives together, not unless you're the IR guys or the IT people. That behavior is pretty deterministic. So I've got to connect to the share. I'm going to push my payload there if I'm going to do it the old-fashioned way, which a lot of bad guys do, or I'll use WMI. And then, of course, I want to execute this payload. So here's service host making the connection. Again, nothing too fishy here, right, other than the fact that Workstation 1's talking to Workstation 2. But lo and behold, what do we see? The new advantage is, what did malware.exe, I renamed putty, malware.exe, but what is the parent? And again, in Windows 10 and Sysmon, you'll see this. WMI PRVSE. So now you have WMI calling an odd binary. Ding, 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 ding. We saw possibly an auth. We saw a network connection. May not have thought that was malicious, but WMI calling a payload. Focus on this guy right here. This is your winner, winner, chicken dinner alert for sure. And you can see it down here. And again, there's no parent-child here. See how flat it is? So it's going to be buried amongst all those other executions unless you specifically say, I want to look for this kind of attack. You can go hunt for this kind of attack by looking through the logs or your SIM or whatnot. And so again, down here, you can see WMI PRV talking to the malware or launching the malware as the parent. So parent-child here is really key. Windows 7 gives you the PID. So in Windows 7 on the left, you're not going to see WMI PRV SE, you're going to see the PID. Okay, or you'll see the process command line in a standard 4688 saying, hey, WMI launched this thing. That's all you're going to see. So this is big. To be able to see this is a cool thing to focus on. And here I show just launching Notepad. So I was just playing to see what else I could do. Well, there again, WMI PRV SE is launching Notepad. Yeah, this is not good. If you see this behavior, you should be freaking out. This should be a very high return rate alert for your environment, because this does not happen very often unless it's a management utility that you vetted and said, yep, that's just an HP whatever, a Dell whatever, et cetera, or storage array whatever, or Intel whatever. But when you start seeing odd binaries, and more importantly, where that binary resides, the directory is definitely the key thing here about where that thing is. I'm just launching Notepad, so it's in System32. The bad payload will probably be in a user subdirectory, like C users, app data roaming, whatever, wherever they dropped it, right? They'll use %temp, and they'll just drop the malware there. They know where it is, launch it at %temp, and bam, it goes and finds it in the path. And again, comms happened here, so you can see the 137, 135 traffic, so you know as, again, yep, somebody did connect to this machine and did that thing, so now I have more data. So what I showed you initially was kind of the backup data. This guy's the big one. Look at the WMI, launching a payload, and now look at the other data to reinforce which direction and where it came from. Because unfortunately, the top one doesn't tell you where. You got to look at the network comms or the authentication to tell you where and who. WMI Service Starting. Yeah, this kind of sucks. So one of the things I noticed in the course of the WinNTI attack is there were some boxes that did not have WMI. They were dumb servers. There was no WMI. There was nothing special about them. And so seeing WMI start with the 7040, which is a built-in Microsoft utility, so you'll see a 7040 event for this, it doesn't raise any flags. If all of a sudden on workstations it starts up 150 times, yeah, you might want to pay attention to that. It'll be already running on servers, but not a lot of workstations won't have it. So if all of a sudden you get the spike in a bunch of WMI services starting, you might want to pay attention to the 7040s. And unfortunately, if you have security tools, the stoppage of a service, third-party service, will not trigger a stop on 7040 event. Only the Microsoft-supported stuff. So your EDR solution and or some other solution like NetIQ or something else will have to be the thing to tell you that, hey, something stopped. Or your EDR solution console will say, hey, 150 of these, as you'll hear in the podcast that's coming out this week, 150 of these workstations, EDR just stopped. Uh-oh, well, something's wrong here. Right? So you have to pay attention to that. But again, there is some noise here, and you will have to understand its context of what's going on. So use WMI to start a task or service. Now, we're back to typical logging. Yay, unfortunately, Microsoft does not enable the task schedule log by default, so you have to go enable it as part of GPO. It's sad. There are other logs in the security log, which I'll mention in a second. But really, this is the key log because they're simple messages, they're low noise, and you can literally look for creates and starts, and that's it. You can filter out and throw out all the rest. Yeah, they deleted it too. You'll find that in your investigation. You don't really need to log that. But the 106 and the 100s and the 110s are really what you're after. And again, scheduler operational log is not started by default in Windows. Please go turn it on. Please, 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 please. I beg of you. Creating a service is noisy. When you do create a service, I don't care who made it, you get a 7045 event. This is the one thing that Windows by default does well. It is on every machine forever for all versions of Windows that I can remember. So you should always look at new service creations in all workstations and servers, by far, period, end of story. The POS software that held the credit card used this. WinNTI seriously used this. So this was a major alert that got us alerted to that cheat sheet that I initially created. This was the big one. This was a really powerful one because they installed everything as a service and they use driver files because they don't log anything. So all of a sudden we had 150 services starting called Splunk driver. Like, wait a minute, I know Splunk. It doesn't. No. And boom, we found it. Unfortunately, when they stopped our Big Fix service and found a cave and infected it and restarted it, we never saw any of that. And so when Big Fix would start up, it would actually read a payload out of the registry, drop it to disk, execute it, and then delete it. We never saw the 150 workstations and servers stopping and starting, redoing that. That would have stuck out because Microsoft doesn't log third-party starts and stops of services. But there's help. So in the more advanced Windows cheat sheet, the Windows Advanced Logging Cheat Sheet, shout out to David Longnecker who helped out with this. We published some of these more advanced settings, one of which is the 4698, 99s, 4700s, 4702s, which are security log, task scheduler log events. But you have to turn on some specific logging, additional logging, which can get quite noisy. Again, original Windows logging cheat sheets try to be as little noise as possible to greatest value, but a lot of us want some more advanced details, and that's where we put it in that one. And again, no third party with 7040s. So what you have to do is modify the DACLs. That's in the advanced logging cheat sheet, and enable a couple other audit items, and then you will actually see the starting and stopping of third-party services. So now you can monitor the EDR, Carbon Black, in-game, whatever, if they don't have it built in, or the big fixes or whatever. You'll have the ability to do this if you want to turn this on and hunt for this item. It's pretty powerful to be able to see that activity. Sysmon is an option, but again, if you haven't listened to Mac Raver's talk, Black Hat, same one, where he talks about how you can modify it. I know Carlos Perez has talked about this and blogged about how he can bypass Sysmon, just change the settings in the registry. You can modify the config and reload it so it borks it and won't load. Lots of ways you can get around Sysmon. So I would not recommend being a major logging device. I would say use built-in Windows logs first and supplement it with the things that Sysmon does really well. And please watch Matt and Lee's talk for more on this subject. But again, you want event IDs 19, 20, and 21 in Sysmon. That will tell you the new root subscription items that were added, and so that's something to watch for if you're using Sysmon. How many people here are familiar with WLS, the government project, Jason McCord? This is Sysmon on steroids. This is an actual syslog service developed by the government, the nuke people that can't use third-party stuff. And this is a serious badass logging agent. It sees more stuff than you could ever imagine anything else seeing. It doesn't look at the logs. It writes its own syslog data right directly to your syslog server, Splunk, whatever. And it collects just an amazing amount of data. All the configs are stored in a registry. I own a personal copy of it. It's incredibly voluminous, so licensing is a concern here. But if you really want to see stuff, there needs to be some work on WMI, but it does see the user call, so you can see what WMI object call was made, and that's what he's logging. So some of the trace log data here. So another option for you guys if you really are concerned about the APT scenarios of that, WLS can really help. So look at PowerShell. You can't have WMI without PowerShell in most cases. And again, don't forget, you have to enable the logging. You got to turn it on. Windows does not turn this logging on by default. So please follow the cheat sheets and get that enabled. And there's a lot to this. So watch my ShowMeCon, gracefully recorded by Adrian. So he posting that has the ability for all of you now to see the PowerShell sister talk about this. So I highly recommend you go watch this video because I share all the interesting PowerShell food that you should collect. And again, detect and hunt for PowerShell, oddball PowerShell. There are 2 logs, the Windows PowerShell old V2 logs. Those still works in 3, 4, and 5, and 6. And also specifically the new V4, 5, and 6 logs, Windows PowerShell operational. This is where the 4100 series comes into play. The PowerShell logs are 200 to 800. So definitely monitor these logs for PowerShell activity. And again, process command line, right? I mentioned this before. You'll see the 4688, but then when PowerShell executes, you're going to see PowerShell executing a lot of duplicate log entries, 200, 400s, 600s, 500s, 501s, 800s, etc. But these, you want to watch for these as well, depending on your version of PowerShell. And of course, if there's any base64 involved, or any odd scripting or obfuscation, the 4104 will actually decode a lot of that for you. So that's the cool part. You'll see this big base64 blob show up, which is probably always bad, like 99.9%. You could then go look in a 4104, and you're going to see it decoded. Very cool. So it does that for you. So very powerful feature of PowerShell 5, 6, etc. Here's Whoamio. So Whoamio is a solution I recommend. If you want a free solution to work at home in your lab, in your testing, Whoamio is free for 2 terabytes of data for 7 days. And I'm always looking for something I can recommend to people that's, again, completely cloud. They have an on-prem solution. I'm not here to promote Whoamio. They're a sponsor of the podcast, but I need something I can do in lab and at home. All my stuff's monitored. So here's PowerShell running, right? So I now know that PowerShell executed. I now can create reports and alerts of the other objects of what executed. So here's PowerShell seeing me execute WMI implant. All right, so here's an example how at home I can do this research and I can monitor all my stuff, make sure, your kids, your wife don't get malware. Well, they'll get malware, you just at least detect it. But very powerful in regards to that aspect. And then you can take what you've learned to work and convert that to your SIM of choice and flavor. And of course, this was a base64 blob, so it gets translated in 4104s. How do I hunt for PowerShell? Well, I love LogMD, but I'm biased. I'm a co-developer of it. But here's an example of the kinds of stuff you should hunt for in PowerShell. The Splunk logging cheat sheet has an example of this kind of logic that's on Malware Archaeology. So again, suspicious artifact. So they're using the buzzword -ENC for encoded. So I know there's something decoded, and also the word bypass. So they're trying to bypass something. I have seen legitimate software do this, but it's rare. So that in itself isn't a warning. But then the very next thing is there's 138 ticks and 264 pluses. Anybody see Daniel Bohannon's obfuscation talks? Yeah. Well, he just caught it right there. The Splunk query and the cheat sheets will have an example of this as well. And it's a large block size. So I know there's a big-ass block, and it's got lots of special characters or potential obfuscation. So LogMD, we have a settings file you can configure to make this really stick out. The last item is the fact that PowerShell is phoning home to somewhere, so it's making an HTTP web client request. These three combinations together should say, hey, somebody's infected, or the box is trying to be infected by something or somebody. And again, this can be initiated by PowerShell. Why? PowerShell is a trusted binary. It can phone out, and your whitelisting is going to be fine with it. EDR should be freaking out right now, too. If it doesn't, don't buy the EDR. Or buy a different one, or something, or complain. But yeah. So some tools to talk about. LogMD, we query all the namespaces. So if you want to come take a look at our booth, well, we're up there. I'm not here to push that. I want this to be generic for anything you use and do. This literally is something you can do with a myriad of tools, scripts, PowerShell, Python, whatever you want to do. If you do anything interesting, let me know, and maybe we can help promote that in regards to an option for people to scan, or if you hear something. And again, we do also have a -WMI option, so we can just scan or hunt for WMI. My perspective of hunting is a little different. A lot of times you hear talks, if you listen to my SANS third talk, which they'll publish in 3 to 6 months, some random time, they'll probably tweet it out. I say start with excluding what you know you don't have before you make a theory or a hypothesis. Meaning, when you watch my SANS talk, there are 4 items on there that I've seen in 95% of all malware I've ever seen. So if you can hunt for that and eliminate, I know I don't have WMI going on, that's bad. I know I don't have large registry keys. I know I don't have any null bytes. I know I'm watching my C users directory structure for executions. I'm looking at my AutoRuns, and I know I don't have any funky AutoRuns. You just eliminated like 99% of all infections right there, because they all have to do one or more of those pieces. So go after what you know you don't have, eliminate that, then build your hypotheses to go hunting. But definitely hunt for WMI, because this stuff is stealthy, it's quiet, and it's easy to infect a system with, because it has lots of power. You just need user, right? Because all you need is creds. Still better than CactusCon. And again, you can use Sysinternals AutoRuns, but again, you're going to be limited to root subscriptions. So if Matt Graber is a contractor you've signed up for pen test, yeah, he's going to screw you here. WMI Explorer will show you all the WMI stuff, but it's way too complicated. But you can query every damn thing in the WMI, but it's huge. I mean, we're talking a list this long of namespaces and subscriptions and whatnot. There's a lot of stuff in there. And a server will be even more complicated with all the hardware from storage and whatnot. WBM Test is a diagnostic tool that's built in the box, so you can actually play with some commands and whatnot there. And you got WMIC as well. So again, I'm going to give you the commands. Yeah, please try LogMD, but here's the commands to actually query the command line to see what's in these various namespaces. So you just have to change the names to the appropriate consumers and whatnot, and you can actually get a dump of what's out there. And again, be sure to watch Matt's talk here so you can understand what he's talking about and understand all the things you might have to change with these queries. So yes, you can make a big-ass script, and you kind of are replicating what we're doing with LogMD. And again, use LogMD to do this. It's a lot faster and easier. WMIC. So here's an example of where WMIC would be used, and I mentioned earlier that there was a .link malware that came out. If you're not blocking .link at the email gateway, you really should. And then it just uses WMIC to use one of the parameters to go out and fetch the stuff from the internet to bring down and infect the machine. This is just a query, so it's those things I just showed you being executed. And again, this isn't malicious. It's just an example of what process command line gives you, all the details. Not, if you don't use process command line, just do process execution, you get WMIC.exe, and that's it. Right? You get what's on the right, but you won't see what's on the left. What you need is what's on the left. Context is king here. You really need to understand the context. Some other WMI tools, again, if you want to get a copy of the payload, here's an example of how to harvest it so you can see what's in there. If you come across a big base64 blob or a big PowerShell blob, you got some homework to do, all right? So you might want to get a copy of it and decode it and do that sort of stuff. Here's an example right here of a decoded payload in WMI namespace that I got from somebody's report. So yeah, it's actually down at the bottom, crypto mining malware using WMI. So there you go, hiding base64 in the WMI database. This is not good. So all I have to do is see that and go, uh-oh. Okay, you guys might have to do more research, but I can tell you right there, you should never see that in the WMI database. And again, the 4104, when PowerShell executes this, will decode that for you, if indeed it actually ran on the box. And I'll give you a link to go to decoder if you harvest it. So hunting for WMI Pwnage. AutoRuns. So first thing, LogMD free as well as Pro will let you dump all the AutoRuns. The Pro version has a bunch of master digest exclusions of all known good hashes and a whitelist to get rid of all the parametered items that you trust. So you can very easily hunt your entire environment with just looking at the AutoRuns that do all the WMI querying. Again, watch out for those other namespaces. So you could start with Sysinternals or whomever and then go through it and say, okay, I know I don't have any of that it can see. Now I only have to worry about what Matt's talked about. And again, look for anything new, anything weird, any base 64, any blobs, any PowerShell. Look at all the scripts that are already there. Anybody seen kernvbs.vbs in their WMI output? What if I added the payload to the end of that script? I haven't changed the WMI database, but I now have persistence because when that script kicks off, it's added my bad foo to it. So now you got to hash all the scripts you see in your WMI database and do a compare against them to see if they've been modified. Okay, so that's another tip for those existing. And Devin Kerr confirmed that he sees a lot of this in the field. So watch out for those already existing entries that are modified from a script. Watch for the 4688s. You can actually, in SIM or log management, go search for 4688s. Do you see any occurrence of the thing WMI? In my SANS talk, I talk about the 3 C's. Completeness, coverage, and configuration. So completeness is, do I have this turned on everywhere? Configuration is, did I turn on all the logging Michael said, right? And coverage is actually the agent collecting, running, and doing the right things and ending up where I want it to end up like a SIM. So you have to take that into account, and because again, if you miss that one box that's infected because they turned off your SIM agent, your Splunk Universal Forwarder or WinLog Beat or NXLog, then your coverage is bad. You're missing something. It's all configured correctly, but it's not sending upstream. So you got to look for that condition as a part of this. And watch for those 4688 executions. They are key in regards to catching some of this activity. Check your PowerShell logs for base 64. Base 64 is not used that often. I've seen some in some SQL Server, more for doing some settings into the registry. But this is not a normal behavior, and even though it's available, it's not normal behavior for the most part. Check your auth logs for 4624 for these odd WMI logins. Again, exclude that you do not have them. And then I don't have those double logins like you talked about in my Win10 boxes. Okay, I can check that off. I don't have that, right? You're constantly trying to eliminate things. Because you're not really looking for it. You can say, I've been hunting for months. Well, you didn't find anything. No, but I know for sure I don't have this, I don't have this, I don't have this, I don't have this, and here's reports of where all that got used. That's a better answer than, yeah, you're right, I didn't find anything and I've been doing this for 3 months. What am I paying you for? Well, because I know I don't have this, right? So it's a totally different argument on how I look at it. Look for those WMI logins and check the WMI activity logs, right? Not a lot of noise here, not a lot of WMI being added to a system. It's definitely powerful for you. So some recommendations. Hunt, please, hunt. Eliminate what you know you don't have. That's a great place to start. And then build your hypotheses based on that, per what everybody else talks about. I would agree after that. Map your capabilities to attack. Start doing this. You want to see an example? Come upstairs. We'll show you our cheat sheets and how that works. The idea there is you're not trying to see how good you are. You're trying to see if you, as your organization, as you're trying to understand how good you are at this area, or bad, or non-existent, you're just trying to say, can I see this item? No, I need a tool for this. Hey, boss, I have to budget an item. I found a tool, and I need this much money so I can cover these boxes that are in red on the attack matrix. You're only going to do part of them. And so you can use that to your advantage to help you kind of justify some budget. These are real techniques used by hackers of all these APTs. We never see APT. And by the way, Commodity uses them too. So argument goes both ways for that. Please look at the logging cheat sheets as well. There's 2 at malwarearchaeology.com/cheat-sheets. Recommendations. Process command line logging, 4688. If I say it enough times, you guys will remember it. Pay attention to parent-child executions. Very important here. WMI PRV-SE.exe, the parent of another binary that's not a true known management software piece of utility. Yeah, you are going to have some investigation to do. Monitor these dual authentications that I talked about, right? Where WMI is the launcher of that, because the process that called the authentication is in there, LSAS, whatever. But if you see WMI doing it, you might want to investigate those as well. Monitor the Windows firewall connections, or however you get that firewall information on the hosts to look for lateral movement, right? The pen testers get on one box, either through a fish or whatever, and then they're going to go east-west, and that's how you're going to get nailed in big time, right? The WinNTI group got into somebody who clicked on a Word doc, and then once they get on that box, they jumped to another one, they got the creds, and they went east-west from patient 1. Patient 0, they never did anything other than initially affect. So you definitely have to start looking for lateral movement because WMI gives them the power of query and remote executions very quietly. So east-west lateral movement is a big component here. Monitor the Windows remote. So WinRM, if you're not using it, how many people here are using WinRM? Is it heavily used? Yeah, fair enough. There's a hand. So if you do use it, watch it and figure out what's normal. In Splunk, you can say, oh yeah, that's this Conza stuff, not that. This is, yep, not that. And get it down to 0. And then when somebody bad, like Benton, gets on your box, oh, I'm going to win RM. Or Tyler gets on a box, I'm going to win RM. Boom, you'll catch them. All right, that's the idea behind filtering out the known good. And again, Windows Remote Management / Operational Logs. It's a long one. Please upgrade to PowerShell 5. My talk from ShowMeCon would be a good place to start. You'll understand why. Monitor PowerShell executions. Generally, there is now more and more PowerShell. If you have Bamboo, Puppet Chef, whatever, a lot of PowerShell being used there. Management utilities are using more and more of it. Dropbox uses it to update. So you will have some normal stuff, but you can take strings out of those blocks, script blocks, and say, yeah, not that, yeah, not that, yeah, not that, to get rid of the noise so that you can quiet down the results. And eliminate that you do not have any base 64. If you do, then make sure you know what the heck it's executing and why, and then ask the vendor, why are you using base 64? To get by AV? I mean, there may be a reason. Size of script blocks. Big-ass script blocks, not necessarily a good thing. So the size of a script block is a clue, but not uncommon. So this is a noisy item, but it is, combined with the other items, definitely helps tell you something's bad. And obfuscation characters, count them. Okay, once you start counting the normal ones, you're going to see what I mean here. The pattern is 20, 25, 30, and most of my boxes in my labs are set at 20. So I get over 20. And occasionally I get a bunch of dollar signs. But when there's some obfuscation going on, it's in the hundreds, 135, 138, like I showed you in one of the examples. And again, suspicious words, which easily can be broken, unfortunately, with obfuscation. But after they're decoded, a lot of times these words will then show up in one of the other event IDs, right? There's a 200, a 400, a 500, a 501, a 600, an 800, a 4100, a 4104, a 4103. Don't do 4105s and 4106. Please turn that off. The bad guys will rotate your logs. You'll never see any of it. There's 9 event IDs, so that's a lot of data here. So one of those will probably catch these buzzwords. And yes, they are case sensitive, so please uppercase, lower this, look for that, especially in your SIMs. Hunt for WMI persistence. Eliminate that you don't have it. Be confident that you don't have it. Hunt for large payloads in the registry. Hey, wait a minute. How do large registry payloads get involved here? If I want to hide my binary and not, they call this fileless malware. Okay. Let's get over the fileless malware stuff. But they'll take their binary that they initially executed on the disk and then deleted, so it's not running right now, put it in the registry, makes a big entry, and, you know, we're talking 250, 300K. So if I go looking for anything over 20K, you're going to see about a dozen keys, and you'll see another dozen keys under the GUID's HKey user scenario, because there's 2 entries, right? HKey current user and HKey user's GUID. And eliminate that you don't have any large keys. This is where CoveTur and WinNTI played. They dumped all their scripts and all their payloads in the registry. Nothing on disk. So if I did a full file hash compare, I saw nothing. Until I rebooted and did stuff and saw it drop and got audit entries. But I know where they hit it, either WMI or the registry keys. Because WMI can call the registry to then load said malware. Because they don't want the WMI database to be too clogged with their bad food. Because you might be looking after this talk. You can also enable file and directory auditing on WBM to look for new entries, 4663. File auditing logging cheat sheet will help you out here. And then the registry, you can watch the WBM key. That actually will show you all the new namespace subscription thingies going on that have been added to the system. And you can catch those with a 4657 if you turn on auditing and you select this key and you say, everyone new created. Don't do reads. That's like 4-to-1 in noise, so just don't do that. But that will be a way you can also detect these additions. Monitor WMI may consider a monitoring solution. So you can actually run a PowerShell script to look for any additions to WMI database. There's several projects out there. I thought I'd mention that because it's kind of interesting. This is a report, WMI versus WMI from, I think, Mandiant wrote it. Yeah, it's kind of interesting concept, right? Use WMI to catch WMI. But yeah, so it's an option to you if you want to do that. If you're in that boat that might be valuable to you, it is an option, and you can write an event ID, and then boom, you can trigger on that. So conclusion, WMI is dangerous. It is not very noisy, as you saw. That malware 8 deep is not like the WMI queries that I saw, all one-liners. Okay, you'll occasionally get 2 depending on what the guy did. And after I played with his research, I realized if I do this each one at a time, I'm only going to have one-liners. If the guy's bad, he'll nest his stuff together and you might get some parent-child relationship, maybe 2 or 3 deep at max. But for the most part, if they're good, they will make a one-liner so you won't see it. And again, it uses built-in, right, living off the land, built-in stuff to pwn you and or expand. So please enable the logging I discussed here. Definitely watch for this and go hunt and eliminate you do not have it. Some additional reading. Put some resources in here. This will be posted on Malware Archaeology under the presentation information. And if you have any questions, I'm here. Please, I have some of these pop-ups. Anybody gets a good question, I will give you one. And then please come chat with us and ask us questions in the booth about some of this stuff and continue the discussion because that's what we're here for, to share and be part of the community. So there you go. And with that, I am done. Questions? We have time for some questions, I think. Or not.